Hi everybody, my name is Scott Weiss, and this is a presentation about LayerX, which is a piece of software developed at EMC to handle centralizing scheduling in Mesos. So a little bit about my team. There's myself, another engineer named Yuval, and our CTO who's named Adi Levine. We got our Twitter handles, and I implore you to check out our GitHub page. We do a lot of cool projects. LayerX, unfortunately, is not open source yet, but we're working on doing that. But in the meantime, there's other cool stuff there that you can check out, all open source. Okay, so a little bit of background. Once upon a time, a few months ago, there was a meeting with the offices of VM Turbo, which this room is actually named after at this conference. VM Turbo does monitoring and scheduling optimization in cluster management and in other data center, like basically anywhere in your data center. But they had a problem. And the problem is that in Mesos, there is no effective way to do monitoring and scheduling because every application that runs on top of Mesos handles its own scheduling. And let me explain a little bit more what I mean. So Mesos itself, for those of you who don't know, it's a popular cluster manager. It's been in use since 2011. It's widely used at hyperscale. So here are some of the companies that are running Mesos as part of their stack for distributed applications. So if we take a look deeper into how Mesos actually works, you have an application that runs on top of Mesos. They call them frameworks, for whatever reason. So the application, what happened there? I think I lost my video. Still up over there? Just keep going, I guess.
Should punch the projector.
Hold on one second. Maybe I can. I don't want to mess with it. Is there anybody here from ContainerDays? No? Can everybody see the projector? Oh.
There it goes.
Okay. I guess if I hold it there, it'll be happy. I don't know. Okay, so as we can see in this architecture, it's significantly different than cluster managers like Kubernetes and Docker Swarm because application does its own scheduling. The Mesos is not opinionated about where things get scheduled, so every application or framework is required to do its own scheduling. In the Mesos architecture, we see three frameworks here. We've got Marathon, which is schedules applications, long-running processes. Jenkins, which is a continuous integration testing framework, and then Cloud Foundry, which is its own standalone platform as a service, but there's also a version that runs as a framework for Mesos. So we have three of these that are sending these little green guys. These are tasks. Tasks get sent to the Mesos master with assignment already made on them, and Mesos distributes them to the slaves, where they're actually running. So how does this transaction work? Mesos sends a node or part of a node called a resource offer to a framework, and the framework scheduler evaluates it and decides whether or not it's a good place for the task. If it's a good place for the task, it accepts it and sends back the task to Mesos, and now Mesos for the first time learns about the task and runs it wherever Jenkins told it to. So there's some pros and cons to this model. The pro is that applications have more granular control over how their stuff runs. The downside of this is that every scheduler is doing its own scheduling, which means to optimize is not a simple task. We can optimize individual schedulers, but we can't optimize the entire data center as a whole. I really lost this thing again, huh? Yeah, sorry guys, 1 second. Okay. Okay. Good enough. Okay. So this is the distributed scheduling model that Mesos has gone with, where other cluster managers have a scheduler basically baked inside of their, like Kubernetes and Docker Swarm, are opinionated about scheduling and do the scheduling for you. They just ask you to send the task, and they'll schedule it. Although you can override their scheduling decision. We'll go into that a little bit deeper in a bit. So this is a problem, like I said, for certain schedulers, certain scheduling algorithms. Sorry, guys. So, why don't we switch to the HDMI?
Because we use sound.
We lose sound.
Yeah, administrator, basically.
Oh, okay. All right. Well, let's just keep going. All right. So you've got schedulers like VM Turbo, and a scheduler created specifically for Mesos called Fenzo, made by Netflix, which also tried to address this issue. But these both require a full view of the cluster in order to effectively work. And the question is, where do you get this full view? Because Mesos only knows about tasks after they've been assigned, after they've already been scheduled. And frameworks only know about their own tasks, and they only know about the resources that Mesos has already shown. So there's some problems that come up from this model. So let's say Mesos shows you a node, you don't like it, but you don't know if there's a better one available in the cluster. Too bad, you only know what Mesos is showing you at any given time. Then, let's say you want to co-locate tasks across frameworks. I have a task from framework A, a task from framework B. I know I want them to be on the same node. Unfortunately, frameworks can't see each other's tasks, so there's no way to co-locate. There's also no way to prioritize tasks. Let's say I have Jenkins is running tasks, but Marathon is actually serving my application to customers. Now, of course, Marathon should always take precedence over Jenkins, but if Marathon is not using my slaves, I should have that extra space available for running Jenkins jobs. Unfortunately, the way that Mesos tries to solve this is with something called a reservation, which basically means I set a fixed portion of my slaves that are dedicated to Marathon. But that means if Marathon's not using them, Marathon has to then go and tell Mesos to release those nodes so that they can be used by other frameworks. Then we have this other issue, which is actually a problem in all cluster managers right now, which is there's no availability of continuous placement. So Mesos, let's say I have two nodes and they're 50% full. I have one big job that's going to take 100% of the node. There's no way right now where I can migrate that 50% onto another node so that I get a full node available for the job of what's called continuous placement, where I can basically always keep placing tasks and moving them around in order to make sure there's as much room as possible for placing additional tasks. So we approach this question: how do we put something into Mesos that's going to show us the tasks before they're scheduled and also show us all the resources that are available? And the answer we came up with was the same thing that we do to solve any problem in computer science. We added a layer of abstraction. And what do we do? Call this layer of abstraction, we called it LayerX, and that's how LayerX was born. So what is LayerX? LayerX is a fake Mesos master and a framework. The way it's actually working is you register your frameworks to LayerX in the same way that you register a framework to Mesos. The frameworks have no idea that they're not registered to the real Mesos. So LayerX then sends fake resource offers to the frameworks and collects all the tasks that they want to run. One sec. Are we still good on the other?
Yeah.
No.
There we go.
All right. We're good. We're good? Both of them? All right. So we're a fake Mesos master in the same way that Mesos collects the tasks. We collect them from the frameworks. The frameworks believe that they've scheduled the tasks, but they actually haven't. They're still waiting to be scheduled. Mesos itself doesn't know about them. Then, on the bottom end of LayerX, LayerX registers to Mesos itself. And because we're the only framework registered, we're collecting all the resources ourselves. Now LayerX has all the tasks from all the frameworks and all the resources from Mesos, and now decisions can be made about global scheduling. LayerX then exposes a REST API for actually good schedulers, like VM Turbo, to come and make decisions about placement, task migration, etc. So what features does LayerX add into the Mesos cluster? So one, we have the option to add in any scheduler, and not just one scheduler, but you can have multiple schedulers attached to LayerX, which are maybe responsible for different frameworks. I can have a scheduler specifically running against Marathon, another scheduler for scheduling my Jenkins jobs, and they can see the entire cluster, even if they're only responsible for making assignments for part of that cluster. We can also intercept and resize tasks. So VM Turbo, for example, an interesting part of their optimization algorithm is that they monitor the task and realize that it may not be consuming as much resources as it reserves for itself. So VM Turbo sees their scheduler sees that a task is not consuming as much resource as has been allocated, we can actually resize the task with LayerX and change it the amount that Mesos has allocated for it to free up space for other tasks in the cluster. LayerX also allows us to now do live migration in order to achieve continuous placement of tasks because it knows where everything's running, and it can move tasks between the nodes without losing its connection to the framework that requested it in the first place. LayerX also allows us to now manage multiple Mesos clusters, which if you've got clusters in different regions that are operating independently, we can now schedule from a single framework tasks across clusters. All right, so let me show you a demo of LayerX in action. So I've already got it set up here because I wanted to set up ahead of time. So we've got two Mesos clusters. This one is in US East on Amazon, and this one is in US West on Amazon. We've got Marathon running, like probably the most commonly used Mesos framework. And this Marathon is actually scheduled to LayerX. And you'll see my really, we lose both again? Still good on one? Okay. All right, one more try. I'll try, guys. Oh, we got another one. Okay. These work. Okay. All right. Cross your fingers. Don't touch anything. Okay. So we have two Mesos clusters. And now here's my really beautiful UI that I did. Just to preface, I'm not a UI engineer. Oh, we lost it again. All right. Not a UI engineer, not the most beautiful thing, but we can see LayerX's view of the cluster. So LayerX sees all the nodes. We've got 3 nodes that are from US East, 3 nodes that are from US West. We have a list of all the tasks that are pending and staging tasks, so tasks that have been assigned, and we're just waiting for them to start. So, let me show you how it actually works. So I'm going to go to Marathon. I'm going to say create an application. Give it some ID, ContainerDays. And we're going to make it like really brilliant application here. While true, do echo hello, sleep 1. Okay, so here's my application. I'm going to schedule it. Now we're going to see it's deploying. Now what's already happened is Marathon has gone out to LayerX, thinking it's Mesos, says, do you have any offers, any available resources? LayerX says, yeah, I have a fake one right here. Marathon says, sure, that's a great place to run my task. I want to start it. LayerX has now received this task. We can see it sitting in the pending tasks. We can even click on it, get all this metadata about it, JSON, whatever. We could even modify it here, intercept it, add some labels, add environment variables, if that's what you want to do. Specifically, this is also where you can resize the task. But let's just schedule it. I'm going to click it, and drag it, and we should see it started on node 1 in US East. And we'll see, if we take a look, the task started. And we see it's running, active, hooray. I can show you a little bit more. We'll scale it. Scale out the 3 instances. We should see 2 more tasks appear in LayerX. Very nice. We can, let's say we're bin packing them. We want them all packed on the same node. No problem. We now are able to intercept and perform our own scheduling that overrides the scheduling of the cluster of the framework that's registered to LayerX. And then we'll see all 3 tests are running. Now let's say we want to do some migration. Let's say this node is too full. We want to move some tasks off of it. We can just click and drag. And this is also all possible through a REST API. We're going to put one there. Let's move one to US West. And we'll see what happened is that now we only have 2 running on US East. This one moved to another node. And we've now got one running on US West. And like I said, there's an API to allow this to be automated. I don't have an actual scheduler written, so I'm just demonstrating with manual drag and drop, which is a nice feature. If you're running in your data center, you want to have fine-grained control over where something's running for debugging purpose. Let me finish my slides up. Okay. So, what's the future of LayerX? What else could we possibly do? So, we're in this middle layer here. We're intercepting everything that's coming down the pipeline from the frameworks. What if we could take those tasks and put them somewhere else that's not Mesos at all? So if we look at these other cluster managers here, Docker, Swarm, Kubernetes, what do they all have in common with Mesos? These guys all speak Docker. These tasks, more often than not, are coming down as Docker containers. This is the direction every ecosystem is going in. So, what does this allow us to do? Basically, we can take this sophisticated, mature Mesos ecosystem and bring it to other cluster managers. We can extract the Docker task out of these tasks, out of the Mesos task, and then ship it to Kubernetes and Docker Swarm without the frameworks ever knowing that they're not running on Mesos. This basically allows us to take the sophisticated Mesos ecosystem and run it on any kind of cluster manager that you prefer. So this is a work in progress. It's not demo ready. But basically there's an interface here on the south side of LayerX that allows anyone who wants to come bring an API or implement an interface that will do the task translation from a Mesos task to whatever kind of cluster manager task. And then it's very simple to plug in any cluster manager you want on the underside of LayerX. So we want to work, the next steps are working on actually getting it open source, which I would beg you guys, if you're interested, go on Twitter, tweet about it, ping people, ping EMC, try to get them, because it's a slow process at EMC to get things open source. And we want to work on these integrations with Kubernetes and Docker Swarm. And so when we do open source, I really wish it was ready for today. Unfortunately, we couldn't get it out in time. But when we do open source, it'll be in this repository. You can follow me on Twitter, Edith Levine on Twitter. And also, you guys should check out my Unikernels workshop tomorrow at 1, if you're interested in that as well. Does anybody have questions? Okay.
If people were going to start doing sort of schedulers that live balanced, would you kind of expect them to be using something like LayerX, or do you think it would supersede it, or?
If people are using what for scheduling?
They were going to try to live balance their containers, just migrate them around.
Yeah. So LayerX opens up the ability to do live migration pretty easily. It's specifically in Mesos right now, but we'll be bringing it to Docker Swarm and Kubernetes as well. So for the ability to migrate a task without disrupting the flow of your data center, basically without the client worrying that a task was killed or something went wrong, LayerX does take care of that. It would be a good use case. Anyone else? Okay, thank you.